Okay, so good afternoon, everybody. I see that one or two people are still joining. This is the last session in the storage stream, but is strangely the first one that we've actually started on time. So getting better at this. So I'd like to introduce Cecilia Carranza-Lewis. We were just chatting before the session started, and it turns out that we actually met some number of years ago, and I won't say how many years ago, when I was doing some work on transactional vSAM redbooks. So, but the scars have healed. From that, I do know that we have a speaker who knows pretty much all there is to know about access methods, and therefore is an absolutely superb person to tell us all the things that we need to know about zOS dataset encryption. So with that, I hope glowing introduction, Ceci, over to you.
Well, thank you so very much, Nigel. All right. So I'm actually pretty excited because this is first time I think I'm presenting to guide share the GSE, and hopefully next time it'll be in person. So thank you for joining the session. So this is new ways to protect your data with zOS dataset encryption. So yeah, I'm Ceci Carranza-Lewis, and I'm an STSM in DFSMS, and currently the dataset encryption architect. But I've been in DFSMS my entire career, over 30 years. So I've done extended format and compression and all different things dealing with data within the access methods, data management. So today I'm going to be talking about for dataset encryption, the supported dataset types, the recent additions that we have, implementation considerations, and then spend quite a bit of time on the migrating to basic and large format encryption, because that's the newest dataset types that we're supporting. So I want to focus some time there. Some recent encryption key enhancements, and then just the last page with a link to resources. So if we start with dataset encryption, and oh, and I did want to mention that Nigel had asked if we could hold the questions to the end. So I won't be taking a look at the chat, but I'll take a look at it after the session ends. So just to let you know. Okay, and so in terms of the supported dataset types here, we have, when we developed, went out with pervasive encryption in 2017, the initial dataset types that were supported for dataset encryption was your vSAM and sequential extended format datasets. So that went out at that time when we delivered pervasive encryption. And pervasive encryption is really a strategic direction that we have in terms of security. And under that were a number of solutions related to operating systems, such as with extended format, middleware, hardware with our cryptographic engines, enhancements on the Z14, and tooling around it. So it was a large number of solutions under pervasive encryption, dataset encryption being one of them. So those are the initial dataset types that we supported. Then we have since then supported PDSCs, and then most recently sequential basic and large format datasets. So just a little bit on each of these. So with vSAM and sequential extended format datasets, these are your SMS managed DASD datasets. We delivered extended format back in the mid 90s. So they've been out for a long time, and we've had many large clients have been using them for a long time. But now when we initially came out with dataset encryption, there was a large number of clients that started moving to extended format where they hadn't been before in order to get encryption. With these extended format datasets, accessing it with encryption, it's transparent to the application, enabling encryption. And with vSAM, you can access them transparently with vSAM and vSAM RLS. And vSAM extended formats support compression, but only for KSDSs and it only supports generic compression. So they don't support ZDC, and it's because of the way that they do their encryption at a record level that isn't big enough to take advantage of what's required for ZDC, Z enterprise data compression. For sequential extended format data sets, it's transparent access when you have an encrypted data set when using the BSAM and QSAM access methods. And we do support compression. We started with generic and then tailored. And then when ZEDC, Z Enterprise Data Compression, was delivered in 2014, we supported that. And that's been a very huge benefit in terms of how ZDC is able to provide a really good compression ratio, minimizing CPU time, and then improving elapsed time altogether. So I do have a performance chart coming up on that. So we initially came out with this data set type, and we were able to cover a large group of data sets by supporting extended format data sets. So that's why we chose to deliver it to begin with. And so, as I mentioned, the middleware applications access is transparent because we're hiding it within the access methods. So underneath the covers, DB2 from the beginning, we were able to support DB2. And actually, that's one of the most initial use cases that people were going to in terms of converting their DB2 table spaces and their logs over to use encryption. And that's been very popular in that from the beginning. So IMS, we do support it for certain databases, but there's other databases that weren't supported till later, like OSAM. There needed some work from IMS. DB2 and IMS under the covers use an internal licensed access called Media Manager, but with small changes there, all the callers of DB2 and IMS, it would be transparent to them. So we were able to handle, have support when we delivered dataset encryption at that time for DB2, IMS, ZFS, no changes needed for kicks. So, and then a lot of vendor support that just went through the access methods were able to take advantage of dataset level encryption at that time. So we did get a broad amount of data there. And then we delivered PDSCs, I think in 2019. And I think it was 2018. And so PDSCs are SMS managed partition data sets, extended. So we don't support PDSs. We only support PDSCs. And we only support encryption for data member PDSCs only. So not program object PDSCs. And the transparent is access when you convert those over to be encrypted. So it's transparent access when using BPAM, BSAM, and QSAM access methods, which are what you can use for PDSCs. And then just recently, PDSCs in zOS 2.5 now supports compression as well, utilizing Z Enterprise Data Compression. So that's new. And I'll talk a little bit about why it's important to support compression in the access methods for these data set types that you encrypt. And so in terms of PDSC compression itself, so it can create compression, and you don't have to be encrypted. So this is just support for PDSCs for that you can compress them even if they are not encrypted. And it supports version 2 PDSCs, and it does support ZDC, and you request ZDC compression now. And this is the first time for PDSCs you're able to compress them at this level with the compaction option. So it does support the ZEDC required and ZDC preferred keywords on compaction, just like we do for sequential extended format compression. So that's the compaction and data class that's supported. And in order for the access methods to support compression for PDSCs, that is using DSN type library, which was what's required for PDSCs, you need to define this new facility class resource, stgadmin.sms.allow.pdsc.compact, When we see the compaction option for a PDSE, we'll look to see if you have that facility class defined. If so, then the system will then identify that as a compressible PDSE. So in order to take advantage of compression, it does use it for when members are more than 64K to be compressed. And the reason for that is in order to be effective for Z enterprise data compression, it does require larger data lengths in order to get a good compression ratio. And so 64K, I think like 32K might be the minimum, but really higher than that is better. So it uses 64K as kind of the minimum amount of data that it's going to compress to be able to use, go off and try to compress it. Again, I'm data members only. And then you can copy PDSEs using IB copy repro, even if they're compressed, because what happens under the covers is that the data will be, if it's going through logical copy, it'll decompress the data, and then on the target, it'll recompress it. So that's handled transparently. And then when you're doing dump, restore, migration type of activities, there's no change there also, because under the covers, it's handling it. And actually those forms are doing like physical types of copies and dump restores. So there's no need to decompress at that level. So transparent to the user, but just focused on data members only. So if we look at PDSEs in terms of what's supported, so just PDSE, it's transparent. So no changes to any of the application levels. And so as long as it's under the covers, it's using data members, then those can be compressed and encrypted. And just to mention, when you allocate the data set, we don't know if it's going to be a data member or a program object. And even when you open the data set, it's not until you write the first member that we identify it as being a data member or a program object member. So it's not something that we could capture early and prevent you from allocating it as compressed format, because we don't know if it's going to be program object or not. So just to let you know, we don't make that determination at that time. So we have to wait until you actually create a member for us to designate it as data member or program object member. So then most recently, we've supported basic and large format data sets. So I've been talking about data set encryption for several years since we came out with it in 2017. So now that we have basic and large format encryption, I'll be spending a little bit more time talking about that. So the access is transparent with a little caveat, which I'll talk about coming up, when using the standard access methods, APIs, BSAM, and QSAM against these data sets. So basic and large format data sets are, and we only support them with encryption for SMS they have to be SMS managed for us to support them with data set level encryption. But these are your non-extended format DASD data sets. So what you kind of referring to is sequential before we came up with extended format, but they're DASD only. So with these basic and large format data sets, you also are able to do EXEP programs against them. And so if the application is using EXEP to access these basic and large format data sets, those applications must change. That's why we say it's transparent using the standard access methods, BSAM, QSAM, but it's not transparent when you're using EXEP. So, and also to note with basic and large format data sets, we do not support compression for these data sets, and there's no intention of supporting compression for these data sets. And the reason we needed a new format, extended format, is because for compression, we need kind of underlying format. We rebuild the data set to support compression, manage it physically at a different layer. The compression is transparent to the application when we're using compression with extended format data sets. And so since basic and large format, there's applications that can do EXEP against it, then really what we would be doing is recreating extended format. So there's no intention of adding that kind of layer to basic and large format data sets. Now let's talk about kind of how what we're doing with basic and large format, because there's other things that we need to do to be able to manage it correctly. So with basic and large format data sets, we had to change the physical representation of the data set in a slight way. So we are adding within the access method an 8-byte block prefix to every block that we write. We put a 8-byte block prefix, which is contiguous to the physical block written on disk. However, it's transparent to the application, that physical block, pretty much, except for when applications are doing DASD space calculations, where they're needing to understand the size of the blocks being written and determining things like developing an optimal block size within the application, or finding out how many bytes are left on the track, that type of thing. Then they might need to change, because they'll need to take into account the 8-byte prefix that we're adding to the block size used when we actually write physically the blocks to the data set. And I'll have another chart with more details on that. Now, when using EXEP, as I mentioned, application changes are required. There's no way for the access methods to get under this EXEP application and do things transparently. So unfortunately, that's why we do need to have the application changes. So in regards to what changes are needed, those EXEP applications, they create their own channel programs to do IO. So that's what they're doing. And so what they need to do is to account for the 8-byte prefix. So when they write the blocks, they have to tack on that 8-byte prefix in a manner that's the same that the access methods would do, in order for the access methods to be able to read and access that data set through BSAM and QSAM API. So in order to help the EXP applications to create a format that's compatible with what the access methods would be creating, we've created a new IgG-ENC macro so that they can use. And so on that, before they write the data out, they would encrypt the block using the IgG-ENC macro for encryption. And so that it would encrypt the block before it writes it out. And then underneath the covers, that processing underneath that macro will be doing the similar calls that we were doing in the access methods. So we actually call the IgG macro internally within the access methods when writing basic and large format encryption. So it's creating the appropriate APIs, cryptographic APIs, and things like that, managing the data underneath the covers. So it makes it much easier for the EXP application to perform encryption and decryption, but it does have to change to do so, to include that macro. And then after it reads data in, it'll use IgG-ENC with the decryption function so that it'll decrypt the data within that block. And the other thing the EXP application has to do, it has to have an indicator in DCBE macro that says my application has been modified so that I can support encrypted basic and large format data sets. And that's important because when you open the data set for EXEP, we need to understand whether we're going to let you touch that encrypted data set. And we will let you touch it when you indicate to us that the application program has been modified successfully. Because if we see an open for EXEP that has not indicated that it's been modified, we're going to fail the open because we don't want the underlying encrypted basic and large format data set to be corrupted in any way. So that's another thing that needs to be changed within that application. And so if we take a look at access, so up on top, we have programs and applications that are using standard APIs, BSAM, QSAM, and some that are using EXEP. So the EXEP applications, the ones in red, have not been modified to support basic and large format encryption, but you'll see one of the EXEP applications has been modified to support it. So anything being touched by applications you need to understand by doing some research who's accessing that data. And if it's being accessed by applications that are just written in BSAM, QSAM, then the underlying data can be converted to use encryption. If it's using an EXP application, again, it can the underlying data can be converted to use encryption. But if you have data sets that are being accessed by applications that support BSAM and QSAM and support EXP applications which have not been modified, that data cannot be converted to encrypted data sets, because then you have the issue with those EXP applications would not be able to process that data, and you'd have application failures. So it's really important that research needs to be made before looking at converting data over to basic and large format data sets. And we do have a vendor, and actually we do have a vendor that has been modified, that at least one that I know of, to be able to do that. So we have worked, when we're developing basic and large format encryption, we were working very closely with vendors to make sure that we supported their needs. Okay, so now a little bit of implementation considerations. So I just mentioned that we're supporting basic and large format. We just delivered it. But if you are working with sequential data sets, the best practice is to convert those to extended format. So there's a lot of benefits on going to extended format, and some clients, as I mentioned, since it's been available since '95, have been using it for many different reasons, most likely for compression and things like that. And also because it allows for 123 extents per volume, so it can grow larger, things like that. But now that clients need to move over to encryption, they're now looking at it, which way should I go now that we support basic and large format and extended format for encryption? So I would say it would definitely look at converting those data sets to extended format and encryption. You could do that at the same time. And but first you do have to evaluate to make sure there's no EXP going against those data sets. So it's worth doing that research and converting to extended format. So extended format has a lot more benefits than encryption, as I mentioned. It supports 123 extents per volume. We supported, initially it was created to use multi-striping for performance, but that hasn't been the key thing people are going with. It's mostly they've converted to use compression when we delivered compression also back in the 90s. And also it supports VSAM extended addressability. So growth of the data set is important here. Now, to use compression, if you're going to convert to extended format, look at also using compression where applicable. For sequential data sets, the only restriction of going to compressed format is if you're using update processing for that data set. So that's something that needs to be evaluated. And we can't support update processing because that would mean if you were to, and this is update processing where you read in a block, update a block, and write it out into the same location. Because when you read it in, we would decompress it. If you were to update even 1 byte in there, we might not be able to fit it in the same slot where we took it from. So that's why we can't support update processing. And it's going to extended format, it's just a DSN type, extended, required, or preferred. I think they just mean the same now. There's no difference between required and preferred these days. And the other restriction going to extended format, system data sets shouldn't be extended format unless otherwise specified, but there are system data sets that do support it. For example, SMF data sets, dump data sets, different system data sets, but we just want to make sure, because during IPL times, the certain system data sets, the support might not be active at that time. So that's why we put that caveat in place. And again, the big one is that it doesn't support EXCP processing. That's why you need to do evaluation to see what applications are doing against data sets before you do the conversion. Extended format data sets, they can't be temporary or VIO, not supported by checkpoint restart or hyperbatch, but those aren't used as much anyway, checkpoint restart or hyperbatch. And In order to help identify data sets that go to extended format for encryption or compression, ZBNA, the Z Batch Network Analyzer, totally recommend that, to use that. It looks at SMF records in order to make the evaluation. It looks at our restrictions for extended format and restrictions for encryption and compression, and it utilizes that to recommend what data sets can be converted to extended format. So highly recommended when you're looking at implementing this. All right, so given that, in terms of extended format, one other thing I want to mention is that to take into consideration is that underneath the covers, we do, even if it's not compressed format, we do change the physical structure by ensuring that every block that you write to the data set is the same length. So when going to extended format, you might see that there's an increase on storage for the data set, physical storage that's needed for the data set, because if there's any short blocks in the data set, we are filling those physical blocks out to be the same length. Every block in the extended format data set is the same length. So here I'm talking about sequential. And actually VSAM is the same case. And we are also adding a 32-byte suffix to every physical block that has pertinent information that we need and to process those data sets, which becomes more important when we're doing compression as well. And for any short blocks, we'll add padding to it in order to make it a full block. So that means in some cases, that when you convert over to extended format, people might say, oh, it's taking up so much, it's taking up more space because we are filling out these to be full. But one thing that you could do is you can allocate as compressed format. Definitely, again, recommend compression, especially with ZDC compression, which gives you minimal CPU overhead. And then also another thing to consider is using system determined block size where possible, so that you can optimize the block size when you're writing these the data sets to extended format. And then there I point to DFSMS using data sets, which has a lot of information and considerations going to extended format. The other thing about going to extended format, as I mentioned, the importance of doing compression. So why it's really important is because once you encrypt a data set, or once you encrypt data in general, any attempt to compress that data after it's encrypted will not be effective, because by definition, you're encrypting data, you're trying to make it a form that the bits are not understandable. So compression is not going to be effective against that data. So since you're using access method encryption, any attempt to compress that data set after the fact will not be effective. So one case, if you have disk or tape level compression that you're then compressing at that level, that won't be effective for these encrypted data sets. If you're using the Z compress option for DFSMS, DSS, DFSMS, HSM, that has been actually very popular because it's using Z enterprise data compression on backup and migration, that won't be effective either. So replicated data using DWDM technology, transmitting that data, it can't compress, you get the idea. So that's why it's so important to be able to look at doing access method compression or application level compression, is fine too, but so that the data gets compressed before it's encrypted. And so we do that. So if you allocate the data set as compressed format, we will compress it within the access method before we encrypt it. So that's why it's really important to take a look at these and going to extended format, because we do support compression on extended format and PDSC as well, PDSC with the support of ZDC. But so any case, can't emphasize that enough, because in order to get some of the disk savings that you had relied on with, for example, tape level compression and things like that. All right. And then just another plug for Z enterprise data compression is the over the top benefit. And now with the Z15, it's integrated. So prior to this, you had to buy PCI adapter cards to install and that type of thing. There was a software feature that you had to buy, which you still have to buy in order to enable zEDC on a Z15, but you don't need the compression cards anymore. So, because it's all embedded. So it even gives you more benefit than what you had before, which clients that were going with ZDC compression were getting huge benefits. Because it was minimal CPU overhead. If you look at the chart here in green, the CPU overhead was very minimal, from non-compressed to compressed. And actually here it's even lower because we're encrypting data. So, and so minimizes the lapse time and really good compression ratio. So over the, can't say enough. And customers were coming and just giving us results saying that it was getting huge benefits going to ZDC compression. So definitely take a look at that as well. So, but I just also want to say, even though I'm definitely recommending extended format, we do now support basic and large format. So if there's cases where you need to use it, and you will, for example, the case where we have vendors that are working with their EXEP applications, and so those data sets will need to be basic and large support basic and large format encryption. And one of the big reasons we went, why we delivered basic and large format encryption is to support our vendor community. And because they're doing a lot of applications using EXEP, writing their own channel programs. And in order to allow them to encrypt their proprietary databases and data sets and such, that's one of the big incentives of us supporting basic and large format encryption. All right, so something when going now to converting to just data set encryption in general, we have the similar value across all the data set types, which I've been talking about this value for the last 4 years. And if you want, I can certainly with your clients go through my session on details of all these different value points. But here, just at a very high level, we protect the data at rest and in flight. And in flight is because once the data set's encrypted, if you're going to do any migration, backup, replication, the data stays encrypted through all those capabilities that we have in DFSMS, storage, DFSMS, DSS, DFSMS, HSM utilities. The data stays encrypted that whole way, so it's totally protected. And then when it goes off, if you've migrated the data set and you're using transparent cloud tiering out to the cloud, it stays encrypted in the cloud too. So super protected. Transparent to the applications when using the standard APIs, as I mentioned. You have control over granularity of keys. You're in control over how many keys you're going to create for your different data sets. What we tend to see and to recommend perhaps is that maybe all the data sets being accessed by one application would use one key. All the data sets and things, databases with another application, perhaps another key, so that you can do separation of keys, and it allows for separation of access to those data sets. So that's something in terms of granularity of keys that you could consider. We have a lot of flexibility on that. The other key thing for clients is separation of access control for data set and the key. So in order for someone to get to that data, that sensitive data in the clear, they have to have access to the data set as they do today, but they also have to have access, SAF access to the key label itself. And so you want to limit to who has access to that key label. Those are the folks or the applications or the address spaces that have access to the data in the clear. So you have your administrators that have access to the data set. Based on the functions that they do, you may be able to then remove them from scope in terms of audit scope or access to that data so that they can manage the data set as a container, as a whole, but not have to have access to the data set itself. And that's why it's really important to indicate that when using DSS and HSM functions, copy, dump, restore, migrate, recall, all those functions, the data stays encrypted the whole time. So the storage administrators performing those types of functions don't have to have access to the key label. However, there might be some things that the storage administrator does within your shop. For example, if they have to transmit data using XMIT, Connect Direct, FTP data sets, if they do that kind of work, they'll need to have access to the key label because those will decrypt the data. Of course, when they're being transferred, they'll be encrypted. And then hopefully when they reside on their target, they're also going to be protected. But in that case, they'll need access to the key label, but you want to limit who has those capabilities anyways. So, so it just depends on who has the need to do that. And then the other thing is that we enable easy to allocate data sets because all you need to supply a key label on a new data set create. You could do it through policy, the RACF dataset profile or SMS, or explicitly through JCL, and that'll tell the system to create that data set as an encrypted data set. So just the same value points across all the data set types that we support. So, and the other thing is key management is critical because you have to manage those keys. Okay, and then for the implementation is the same across all the steps. You create your keys in step 1. Step 2 is you set up your SAF controls for the key label and a couple of other things. You identify the data set by tagging it with the key label when it's allocated. And then if you're using DB2 IMS databases, you can do a non-disruptive migration, convert those. If you have batch jobs, they do have to be copied over to create a new data set. And that's it. Of course, key management is key, always. And so when allocating a data set, as I mentioned, you can specify a key label through different aspects. Through the RACF dataset profile is one that we say is the best practice, and that's the highest order of precedence. And that's because the security administrator would then have control over the policies of what data sets are encrypted and what key labels are used there. So for every data set that's encrypted, we have an encryption key cell that we create that has all the encryption information in there. And for every data set that's encrypted, we also have a flag in the format 1, format 8 DSCB indicating it's encrypted. And that's all important because then it allows system services to identify those because we have the attributes. That can, anyone that displays attributes of data sets will now be able to indicate whether it's encrypted or not. ListCat, ListVTalk, things like that. To prepare the data set for encryption, I just realized I'm talking quite fast, but sorry about that. To prepare the data set for using data set encryption, we will honor the key label in the RACF dataset profile. So when we see an allocation, we see the key label, we see the profile. We'll look to see if it's a supported dataset type. And then we'll look to see if it's in the RACF profile, we'll go ahead and create it if it's a supported dataset type. If it's not in the RACF dataset profile, but if we see it in another source in data class or the REC or JCL, et cetera, then the system will look to see if you have read authority to this allow dataset encrypt resource, facility class resource. That will tell the system to say, allow the key label to be supplied on those other sources. The reason we created this facility class resource is that for some clients, it was really important for them to only allow the security administrator to control what data sets were encrypted. And that would be through the RACF dataset profile. So they didn't want someone to do it through JCL or data class in data class because the storage administrator might have control over maybe removing the key label from data class potentially. So in any case, that was a requirement for clients that we are addressing it this way. The next one, for unsupported dataset types on that system, we will ignore the key label and create an unencrypted dataset successfully. We'll give a message saying we're ignoring the key label because it's unsupported dataset type. However, if you want that allocation to instead fail, then you give read authority to the invalid DSN type ENC resource class, and that allowed to fail. So it's just options on how to treat it on the system. Now, for the new dataset types, in order to indicate that these new dataset types should be supported on that system, so for PDSCs, you need to define, you don't have to have a read authority, just define, they act as a switch, the allow PDSE encrypt facility class resource. And similarly for basic and large format datasets, you will have the dataset.seq.encrypt facility class resource to tell the system allow these datasets now to support the key label and become encrypted. So just some restrictions on dataset encryption. So I already talked about system datasets for extended format. We have the same requirement for encryption. And let's see, we have a minimum block size of 16 bytes that's because CPACF, which is the crypto engine that we use to actually encrypt data, that has a minimum data size of 16 bytes. So that's the minimum we can encrypt at one time. That's why we require a block size of at least 16 bytes in order to support encryption. And then we only support 3390 device types, because otherwise, if we support both, we might have to do some reblocking, which means DSS processing would have to decrypt and recrypt, and we didn't want that to happen. So that's a restriction. Okay, now I'm going to talk a little bit more about migrating to basic and large format datasets. We have additional restrictions there because now we can't control over what's being written, because you can write blocks of any size and things like that. Whereas for extended format, we knew every physical block was a certain length. But here with basic and large, we also now have to restrict any user block that's written within the application is a minimum of 16 bytes. So there might be cases when we find a block, someone's written a short block that is not expected. We will have to fail that write. So that's something to keep in mind. And also LRECL, now we're limiting that to 16 bytes for fixed block or 12 bytes for record format variable block, because of the minimum size as well. So that one we could catch at open time, but if the application decides to write a short block on its own, we can't control that. We don't know that at open time, so that means we have to fail that at the right time when it's written. So other restrictions is we don't support key length, and that's the hardware keys within a block. We don't support that. We don't support BDAM accessing these data sets, and we don't support checkpoint restart for encrypted basic and large format data sets. As I mentioned before, that we do have an 8-byte prefix to every block, transparent to the BSAM QSAM applications. I already mentioned that the EXP application will have to handle that prefix. And the reason for the prefix is because we are using this encryption mode of XTS processing, where we have to give a unique identifier to every data that we encrypt. And so since we encrypt at the block level, we have a unique identifier of a block level. There's nowhere we could have stored that unique identifier other than with the block itself was the safest way. That's why we have that. There are some special cases where you can create a data set without a prefix, but for those special data sets, the access methods will not be able to process them. So that's just some considerations to take in mind for these non-prefix data sets. But in general, we will require the 8-byte prefix. And for data space calculations, here's where some people maybe are hard coding half track within their application or using track calc to derive a optimal block size, which is half track. Track calc doesn't know anything about the characteristic of the data set. So it doesn't know it's encrypted. So it doesn't know that it needs to incorporate an 8-byte prefix. So look at your applications. If it's using track calc, you'll need to incorporate the length of the 8-byte prefix into your block size calculation in order to call track calc. We have is it managed has been enhanced to, you can call it and ask for the prefix, and we'll give you the length of the prefix associated with the data set. So it'll be 8 for these standard basic and large format encrypted data sets. Now, we do recommend if applications were hard coding the block size or whatever, we do recommend converting over to the system determined block size, because that under the covers will take into account that 8-byte prefix, because it knows that the data set's encrypted and basic and large format. So I already mentioned that in order to start honoring a basic and large format dataset, you need this facility class resource, dataset.seq encrypt defined. But before going there, research is really needed in order to determine, can we really convert these datasets over to be encrypted basic and large format datasets because of the restrictions I've mentioned before. And so some things to look at is, and this is just a couple of things to look at. So what do you look at to see if that 8-byte prefix is going to be an issue? Again, and this is, we're working with a client exactly in this because they've hard-coded half-track blocks within applications or in JCL. So they're looking at, how do we reverse that? How do we change that to maybe remove it or say block size equals 0? So that system determined block size can take control. Now, the only time system determined block size cannot take control, and that's where when the data set's allocated new, we derive a block size, and which can be adjusted at open if the block size changes, with rec form equals undefined. In that case, we can't derive a system determined block size, but for the other cases, we can. So if you don't make any changes to the application, it's going to be successful. However, you might be very inefficient in storage because that 2 blocks per track will become 1 block per track. So you're going to waste a lot of disk space. So that's something to keep in mind, why you need to do that research first. And the other thing is look for applications that are using EXCP, EXCP-VR, or XDAP. And we tell you, and I also put this within our publication using data sets, what to scan your programs for. And we also have indicators, indicate the indicators in the SMF 1415 records and the 42-6 records, what flags and fields to look at to identify whether you have EXCP applications accessing the data sets. So you're able to look for those in order to do that research. Again, you can also use ZBNA to identify what data sets are accessed by EXCP in the case, because it's looking to see that when it's determining if they can be converted to extended format or not. And so how to handle, so identify the EXCP applications. So determine if they're in-house. You could review product documentation from vendors to see if they support it or not. Encrypted basic and large format data sets for their products, and then make sure those are converted. Now, not to say that all the vendors are planning to convert to use basic and large format encryption or even IBM programs, but it's some research that needs to be made before you do that conversion. So if you don't make any changes, then you have the potential, and if you don't do that research, you have the potential that there might be EXCP applications that will start failing those when they try to get to data sets that are extended, encrypted basic and large format. Okay, and the other thing to consider is if you're already using dataset encryption and you have key labels where underneath the covers, the data sets were basic and large format, but they were ignored before. But now that when you define basic and large format to be supported on that system, they'll start automatically becoming encrypted. So that's why, again, do the research before you define that facility class research saying it's enabled on what may be already within the different under key label that it's already looking at basic and large format. So if you don't do that, then you have the potential for creating automatically basic and large format as encrypted where you didn't intend to. So just more research needed there. And how do I know what can be converted? In the using data sets, I identify all these different things that you can research in order to identify the programs and things like that that might be using, falling under these different restrictions and using EXCP. All right, so that's a little bit about migrating over to that. And then the other thing I want to indicate is, again, ZBNA, can't talk about that highly enough because it was enhanced greatly when we did dataset encryption and actually even for ZDC compression to identify if you're going to convert over what's the overhead on encryption and what's the cost of doing that if I were to start encrypting data sets. Now focused on extended format because it hasn't been enhanced to make the overhead evaluations on encrypted basic and large format, because actually it requires some more SMF information from us fields that we haven't been able to deliver to them. But it does give you the information based on extended format. And I believe it might cover PDSC as well. Not positive there. But it also gives you the estimation if it were to be compressed and encrypted on your system before you even do that conversion. So very good information there with ZBNA. Highly recommended. Okay, so now getting to a couple of key encryption key enhancements that we delivered. So when people determine that they want to convert over to use dataset encryption, they'll need to, if it's batch applications, copy the dataset over. So that might be tedious and take a long time. So especially if you want to do a lot at a time. So Dataset Mobility Facility, ZDMF, can be used to do some of that for you because it does conversion in bulk. So it's able to convert non-encrypted extended format to encrypted extended format. And now it's able to convert basic and large format to encrypted extended format. And it's able to now convert with the recent change, non-encrypted basic and large format to encrypted basic and large format. So it does that in, you could do it in bulk. It doesn't cover 100% of the data because there are some restrictions based on block sizes, but you can capture maybe quite a bit of data that'll help you do that conversion. And the other thing is that even though it's not 100% non-disruptive, there is just a tiny window of application downtime that's needed compared to as if you were doing Jenner or ID cams copying data. So it is beneficial to be able to do that kind of bulk conversion. The other thing that's beneficial is that it'll allow you to do key rotation because you can then convert from one key, encryption key, to another by doing this kind of rotation, copying. So that's something to take a look at. And something in 2.5 that we just delivered is support for archived keys, read-only archive or decryption-only archived keys. So, and this allows you to use this for key rotation capabilities as well, because ICSF archive key, typically when a key is archived, we aren't able to use it to encrypt and decrypt data. But years ago, they had a facility class resource called archive use that said, here's an archive key, but it's okay to be used for encryption decryption, even though there's on this system, even though it's archived. So now what they've done is they've developed the new facility class resource, the archive data decrypt facility class resource that says on this system, allow archive keys to be used, but only for decryption purposes. So maybe you're going to do rotating keys. You want to be able to take data sets and decrypt them, but no longer use that key for new data set encryption. So, but you're able to decrypt data sets from one key to another key that now is a new key. So that's where that will come in very handy for people that are looking at key rotation. And so what we're doing within the access methods to support that is that when we see a key that's an archive key that's decrypt only, we're going to fail open for output, but we're going to allow open for input for that data set. So we're going to do it at the open level when we're processing that data set. And with IgG-ENC macro, we're going to fail it when it's going to be encrypted. So we'll allow decrypt, but fail on encrypt. Okay, minutes left. So this next page talks about key management tooling. So nothing necessarily is new on this page. 3 things we support ICSF. That's what we require for our keys, creating keys and things like that for ICSF. TKE workstation was used with the master keys on your Crypto Express to make sure those keys Those are the master keys that are used to protect your encryption keys within your CKDS, cryptographic key data set. Those where you're protecting your keys as secure keys. So you can use TKE to help you manage those master keys in Crypto Express and transfer them and things like that. So important there. Not required, but recommended when you're starting to build out your key management policies. The other one is EKMF. So the EKMF is a highly secure key management system that can manage lots of keys. You could do it on your own. Again, it's not required for data set encryption, but when you're starting to manage more and more keys, you need to make sure you have good backups, secure them, and things like that. EKMF is what can help you do that. So recommended. We don't use SKALM. That's more for hardware level encryption. Just a little bit more about EKMF, because recently, I think it was this year or last year, they delivered EKMF Web. Before you needed a workstation, a setup in a physical location, but now, yeah, it was delivered last year. Now there's EKMF Web where you have it, you could do it at system level. You have EKMF agents on your different systems working with a set location that's doing management. So it does a robust key management, and it has a lot of abilities to protect your keys. Like I said, back up your keys and manage your keys, create keys, a lot of different functions. So that's something definitely that's very valuable to clients that are having to deal with more and more keys, especially if you roll out data set encryption, that you're going to have to keep these keys long-term. The keys have to be around for as long as you have that data set, even though if it's backed up for a long time, 10, 20 years, the keys have to be around for that long. So if you use a secure, robust management system like EKMF, that's something to consider. So it has a single repository to manage things, has metadata around it, handles backup and recovery. You don't want to lose your keys, give it to EKMF to handle it, that type of thing. It handles key generation. It allows you, it has a dashboard to look at your data sets, what keys are being used, and the data sets being using them and things like that. So it has a really nice dashboard. And it allows you to create roles on the different things people could do for those keys. So there's just a lot, and it allows for auditing as well on how the keys are used. So a lot going into EKMF and continues to be enhanced. All right, and my last chart is a list of resources. One thing I want to highlight is we do have a new Red Book that has been enhanced to support the new dataset types, to include the support for the new dataset types, and also has a big section on EKMF web processing. So, and we do have the content solution page, and I referenced a couple of pubs like the DFSMS using datasets pub, which has the dataset encryption section that has a lot of details in there as well. So I talked really fast and I talked a lot. So I don't know, Nigel, if there were any questions in the chat, but let me just finish this off by thanking you for attending before we open it up for questions in the last few minutes. My email is here. Definitely anyone that's interested in finding more information, having me work with your clients, with your organization, very happy to do that. And then with that, also, I would request that you also fill out the session feedback. And so with that, Nigel, is there anything that came up?
I haven't seen any questions because, to be honest, you answered them all already, whatever they were.
Okay.
So,
okay, excellent.
Very thorough session. It's always good to understand why things work as well as how things work. It always makes it much easier for me to remember, certainly. So everybody can, you can all unmute yourselves if you wish to ask a question, or you can drop it in the chat. I've put the link for the conference feedback in the chat as well, so you can just click on it rather than having to type things.
Thank you. Yeah, I did talk a lot, and I had a lot of details because for some of the things that we designed, I think it's important for clients to understand why we designed it the way we did. And so hopefully that helps them kind of get on board for for some of the nuances
Oh,
when going through.
absolutely, and I,
Yeah.
and I think that's the value of these kind of sessions, for which
Right.
I thank you.
Okay.
Okay, I'm not seeing any questions. So with that, then first of all, very many thanks indeed, Tessie, for presenting to us. I think it was your first time at GSE. I hope it's not your last.
Me too.
And thank you very much to the attendees. Final advert for the feedback form, but otherwise, thank you very much for attending late on for some reason I think it's Friday, but it's not, it's Thursday, because it's the last day of the conference. Thank you very much for attending, and I'll now close the session.